All right, so here we go with 5.1 models of the atom. Now, we talked a little bit about Democritus and Rutherford and whatnot, and that kind of helped us get to a place of understanding a little more about the nucleus, but not a whole lot about the electrons. So the first model we're going to look at now is the Bohr model, B-O-H-R, from this guy called Niels Bohr. And he started looking at the electrons and where they are in an atom, because Rutherford's model couldn't explain the chemical properties of elements, and the chemical properties of elements are related to the electrons. So he proposed that electrons are found in specific circular paths around the nucleus. So if here's just any old nucleus, right, I'm not going to draw the specific protons and neutrons, right? Niels Bohr proposed that electrons would go in specific paths. His proposed ones were circular. As you guys have seen, I am the world's worst artist, so let's use our imaginations to pretend these are circles, right? Well, this is even harder on this tablet than on paper. Okay, so he proposed that electrons would be found specifically in these circular orbits, not in between. Okay? And he called these orbits shells. Okay? And let's say an electron's moving along in this shell here. It could be bumped up to these other shells. Not in between, but specifically to these other shells. If it gains just enough energy, it has to get just the right amount of energy to bump it up one shell, or the right amount of energy to bump it up two shells. Okay, but once again, he said that it couldn't be between. Now, the amount of energy it would take would depend on how close the electron is to the nucleus. Because let's think about it for a minute, right? Just like in a magnet, when you have a north pole of one magnet, right, and a south pole of another, what are they going to do? Right, they're going to be attracted to each other. Okay. Now, since the proton has a positive charge and an electron has a negative charge, they're going to be attracted to each other as well. Right, opposites attract. The closer they are, the more attracted to each other they are. Just like in the magnets, the closer you get the magnets, the more attracted. The further apart, the less attracted they are. Okay, so let's go back to our atom here. You have this positive charge in the nucleus. You have a negatively charged electron. The closer they are, the more attracted they're going to be to one another. So what that ends up meaning is the closer an electron is to the nucleus, the more energy it will take to move it to a higher energy level. If an electron's already starting out here and we want to move it out to this other energy level, boy, I am bad at drawing circles. We want to move this electron out to here. We won't have to pull quite as hard to move this electron to here as we would have to pull to move this electron to here. Okay? So moving it out, you have to put in some energy to move an electron out. To take an electron and move it down to a lower energy level, and the energy will be given off. And we're going to talk about that. Well, actually, not me. I'm going to use one of those other guys' videos in a couple of chapters to talk about how the energy is released when an electron goes from a higher energy level to a lower one. Okay, so the more modern version that kind of builds on Bohr's model is called the quantum mechanical model. And quantum mechanics is actually one of my favorite parts of chemistry, and it's kind of unfortunate that we don't have to go into too much detail in the Regents curriculum, so I'm not going to, because I don't want to give you a whole lot more than you need. If you want to know more about it, there's a lot of interesting stuff in Chapter 5 where you can ask me questions, come to Extra Help, and I'd be happy to show you. But I'm not going to make you write down stuff you don't really need. But so here's what you do have to know. The quantum mechanical model determines the allowed energies an electron can have and how likely it is to find the electron in various locations around the nucleus. Holy cow, what does that all mean? Well, in a nutshell, in any given moment, you can only predict where electrons should be, as opposed to having very specific orbitals, electrons are in a cloud. All right, so here's a picture out of your book, and you can see here, right, here's a nucleus in the middle, and this area here is referred to as the electron cloud. At any given moment in time, an electron can be anywhere in this cloud. However, there are certain places where it's more likely to be, and those are going to be the darker shaded places. And what we're going to learn a little bit about is what those places are called. There's still energy levels, which we're going to look at in a moment. And within those energy levels, the closer an electron is to the nucleus, right, the more the nucleus is going to pull on it. The further away it is from the nucleus, the less the nucleus is going to pull on it. To take an electron and move it away from the nucleus takes energy. You have to put energy in. As electrons fall down closer to the nucleus, they give off energy in the form of light, usually. All right, so a very brief, very simple amount of information about these energy levels. Okay, the electrons occupy energy levels with a maximum number of electrons allowed in each energy level. So any particular energy level can only hold so many electrons. Okay, so we'll look at, for each energy level, there's a maximum number of electrons. So the first energy level, right, also known as the first principal energy level, so principal energy level 1 can hold a maximum of 2 electrons. Principal energy level 2 can hold a maximum of 8. Energy level 3 can hold up to 18. Energy level 4 can hold up to 32. There's actually a mathematical formula of that, which is called 2n squared. Right, so the first energy level, 2 times 1 squared. 2 times 1 squared is equal to 2. For the second energy level, 2 times 2 squared. Right, 2 squared is 4, times 2 is 8. 2 times 3 squared. 3 squared is 9, times 2 is 18, etc., etc., etc. That's how these work out. There's a little more detail that we'll go into when we're looking closer at the periodic table, just because I believe it's much easier to understand if you learn that and the periodic table at the same time. But for now, knowing about the different energy levels will be enough. All right, that brings us to the end of 5.1. See you guys in school.